Good morning. Today we're going to be reviewing some of the things we learned from this week with slope and then applying it to some real world situations. And then we have a quiz tomorrow that will cover all the things you see on this video. So the first thing we did on Monday was this right here, describing slope. It's just words, it wasn't numbers, but it did help us down the road to make sure we get our positives and negatives with slope right. And then anytime we have the zero or undefined, we don't have to find the numbers. Those are special ones. So these two down here, we don't need numbers for those. The number for the one on the left would be the number 0. And for the one on the right, undefined, straight up and down lines, they don't have any slope. So we stay with the word undefined. We call it undefined slope. All right, and the second thing we learned how to do was to find slope from a graph. And that means we wanted an answer that was numbers as a fraction, not just positive, not just negative, even though that helps. For example, this graph is going up from left to right, so I know that my final answer is positive. So even if I make a mistake in my counting, when I get to the end, I know to check and make sure that I have a positive answer. Because if I had negatives in my answer, that would definitely be wrong. This graph is clearly positive. So then we counted rise and run, and you can see the little slope triangle that I drew in here to count your rise and run between two dots. And we did rise of positive 2, run of positive 3, and we got that slope fraction, 2/3. All right, then on Wednesday, we learned about the slope formula. It is a formula for when there is no graph. And the formula is just a simple subtraction fraction. It's highlighted in blue there, y2 minus y1. And if you're curious where those numbers come from, the y2 is the y-coordinate from point number 2, and the y1 is the y-coordinate from point number 1. And then the denominator x2 minus x1, and again, the x2 is the x-coordinate from point number 2, and the x1 is the x-coordinate from point number 1. So there's an example there down below, and the only thing you really have to be careful about here is to remember that there's always a subtraction in both numerator and denominator. That's always there. And when you subtract a negative, like we do down here in the bottom, 3 minus negative 2, those two minus signs will act like a plus, and 3 plus 2 made 5. And then don't forget always to reduce any fractions at the end anyway. So today we're going to take all that work and we're going to put it to a real world problem. It says to rent a bike, Max pays a flat rate plus an hourly rental fee. The graph shows the amount C in dollars he pays based on the number of hours T he uses the bike. So again, he's renting a bike. Looks like it cost him $5 to rent the bike, and then it's some sort of price for every hour that he uses the bike. Ours is to find the slope of the graph and explain what information it gives about this situation. So we need to find slope. That's what we've been working on. When we talked about finding slope, we kept mentioning how it was important to find spots at corners. Because, for example, if I find this spot right here, and I want to find it between these two spots, how much is my rise? Half a square? 2/3 of a square? I'm not really sure how much of a rise it is. So picking spots out there in the middle randomly is a bad idea. But if we can pick spots that cross at corners, it makes it a lot easier, because now when I count my spaces, I'm counting equal size spaces. I'm counting up one space and right two spaces. All right, so let's find that slope. Let's find the rise over run. Well, like I said, I counted up one space. That would be a positive. And then I counted right two spaces. That'll also be positive. But are these graphs counting by ones? So let's look. On the left-hand side, when it's talking cost in dollars, those spaces are not counting by ones, they're counting by 5s. So the rise, although it was only up one space, how much did it actually go up? Well, it actually went up 5. Now the denominator, the spaces are counting by ones. These are time and hours down here, and the spaces are counting by ones, so that the denominator, that will actually be the two spaces. That was correct. So the slope isn't actually 1/2. It's actually 5/2 because of the weird scale on the left-hand side. And you have to be careful about that in real-world situations. We don't always count by ones every time. All right, now the second part of that says, what does that actually tell us about the graph? Well, let's put those symbols in now. That 5, that was from the y-axis. That was our rise. That was cost in dollars. Let's put the dollar sign in. And then the bottom number, the 2, we went right 2 spaces. That was all about time in hours. So let's put the word hours in. Now we have an actual word answer. So what this is, and we read the fraction bar as the word per, we would say that this is $5 per 2 hours. So every 2 hours he rides the bike, he has to pay another $5. That's what that's telling us. Just putting the numbers in from the x and y axis and the words to go match with it. All right, you have a couple of these in your work today. Now, it should be pretty short, but again, it's a little bit harder because you have to read through some things first. All right, good luck. Let me know if you need any help. You know how to get a hold of me on the Zoom, and if you don't, you should probably try doing that sometime when the things are hard for you. All right, good luck today.